welcome back to Allen High School's discussion of electrochemistry at the AP/IB/HL level. We're studying this reaction between lead and chromium, and we want to see if there is a way to separate these half reactions so that hopefully we can capture the electrons and use them to do useful work. So what I'm going to do is I'm going to build a system. So if I'm going to capture these electrons, I can't have the lead in contact with the chromium solution. I have to put them somehow into separate compartments. So I'm going to have two separate compartments here. We can just think of them as beakers. Okay? Now, if I want this reaction to proceed, I need a source of lead. So let's take a look at that. So I'm going to put some lead in here. That's just going to be solid lead. So we're going to call that PB. And on the other side, I'm going to need solid chromium. I want to have complete half reactions on both sides of this cell. So this is going to be my chromium, my solid piece of chromium. Now, inside each, I need a solution that contains the ions. So on this side, I'm going to have a source of lead ion. So I'm going to put lead ion, and I need to counterbalance that with an anion. So I'm just going to have some nitrate in here. So I'd make a lead 2 nitrate solution on this side. And on this side, I'm going to add some chromium ion, and I'm also going to include some nitrate because I need a counter ion, that negative ion there. Now let's write our half reactions underneath that we discovered from last time. I'm going to make this very colorful this time. So I had 3 leads, and remember lead was being oxidized to 3 lead 2 pluses, plus that would be 6 electrons. Chromium, the ion was being reduced to chromium metal, plus 6 electrons went to chromium solid, and I needed a 2 and a 2 here. So what's happening here is the lead is coming off the lead bar and forming lead ion. So do you notice I'm increasing my positive charge in my left-hand cell? My chromium is plating. So this would be corroding, would be a good word. You would see pitting in that lead. This would be corroding, and on the chromium side, I would be plating chromium. So do you notice here in this half cell, we have a decrease in the positive charge there. Now, this is called the lead one, where oxidation is occurring. Trying to find a pretty color there. This is called the anode. So we would call this our oxidation half cell, or oxidation cell, and this would be our reduction cell. Now, these are generally called electrodes, and the oxidation electrode is called an anode, and the reduction is called the cathode. Now, there's a couple of ways you can do this. You can remember this. The R is a consonant and the C is a consonant. O is a vowel and the anode is a vowel. Another way we learn this is to memorize the phrase an ox and a red cat. Anode is oxidation, reduction is at the cathode. So just a mnemonic device to help you learn those. So we've separated these, but there's a problem. They can't communicate with one another. Right? We have to have some pathway for the electron to flow. So we need to include some wiring here. And in the middle of that wiring, we need to have a box. Now, we don't know what this box is right now. We don't know if this is, say, a power supply, or are we going to measure it? It could be a voltmeter. If it's a power supply, that's going to mean it's non-spontaneous. If it's a voltmeter, we're talking about we can measure the voltage. It would be spontaneous. Sometimes you'll see a light bulb put in here to indicate that if it's spontaneous, it's going to light up the light. Power supply, another way to do the power supply is a battery. Okay, there we go. Saw my little text there. Now, let's take a look, and that we're not going to discover for another movie or two, all right? So right now, this is just some sort of black box. Now, you notice that it's oxidation that is releasing electrons. That will always be the case. So that means my electrons are going to flow up here. Okay, so the ion is going to form, and its electrons are going to flow up the electrode, the conducting electrode, into the wire, and then they're going to flow into the cathode, down the cathode. Those electrons will meet my ion to form my metal. Okay, so that's how we plate out on the cathode. Okay, so we're building up a little bit better picture here. Okay. Not quite done yet, so let's see a couple of other concerns that we're going to have if we're going to use this system here. Number one, let me make a note of this. If indeed this is corroding, that means it's losing mass. If this is plating, it's gaining mass. A student came up with anodes or anorexic, which I think is kind of creepy, but it sort of works. They lose weight. You know, you can think of a big fat cat. Cathodes gain weight. If you have a much more pleasant way of memorizing that, I would love to hear it. Okay? And we need one more thing before this is going to operate. If indeed we are gaining positive charge here and losing negative charge here, that unbalanced charge will make the cell stop. And so we have to find a way of connecting these cells so that not only can electrons flow, but we can balance the charge. And we do this by providing a salt bridge. Electrons don't flow in the salt bridge. Ions flow in the salt bridge. Now, we have some ions present already, and those can flow. It's also common to use something like potassium nitrate in your salt bridge. Now, the salt bridge could be filled with potassium nitrate. The salt bridge could be a porous barrier. And I'll show you in the class, I'll show you that we have these porous cups where we could nestle one inside of the other. The key is we have to have a way for ions to flow. Now, since we have excess positive here, we need to allow negative anions, not electrons. Electrons don't flow across the salt bridge. If anions flowed across that salt bridge, notice anions flow towards the anode. That would balance out this excess positive charge that we have here. Now we're losing positive charge on the cathode side, so we would need positive cations to flow to the cathode. So they flow towards their namesake. So this is going to replenish the loss of positive charge. And on this side, it's going to counterbalance the excess positive charge. So anions flow towards the anode, cations flow towards the cathode. Let's refresh, let's complete this chart here. Oxidation occurs at the anode. Reduction occurs at the cathode. Electrons always flow from oxidation to the reduction half cells. In other words, from anode to cathode, you can think of it that electrons flow alphabetically here, either anode to cathode or oxidation to reduction, or they flow from vowel to consonant. A lot of ways to think of it. There is a loss of mass at the anode, and there's a gain of mass at the cathode. I want to make an important point here. This assumes that the anode and cathode are part of the half reaction. We're going to see that's not always true. Okay? Wow, that's been a lot. And we're going to go on in the next few videos and find out, do we need a power supply or are we going to get energy out of this? So until then, this is signing off.